Alright, good morning guys and welcome back. It is Tuesday, April 7th, and this week we'll be looking at exponential growth and decay functions again. Just to review, an exponential function is a function where we have an x in the exponent. And last week we looked at a little bit less specifically y equals a times b to the x. But this week we're going to be focusing on a more specific type, 1 plus r to the x. So we're not just going to focus on, this is a number. We're going to look more closely into that base of our exponent. So exponential functions come in two types like we talked about last week, exponential growth and exponential decay. And to identify the difference, we're going to look at the number here in the base of the exponent. So anytime you're working with pen and paper at home, I want you to really circle the whole power here. Circle that base and the exponent. And in the function y equals 4 times 1/2 to the x, where you can see I already circled that power, we're going to focus on the number 1/2. And a number smaller than 1 indicates that it will be exponential decay. When we say something is decaying, we're saying it's getting smaller and smaller. It's losing weight, it's losing material. So if a number is smaller than 1, it means that that function is getting smaller as time goes on. And a number that's bigger than 1 is going to be exponential growth. So over time, that function is going to grow. It's going to get bigger. And 1, again, is our sort of boundary. That's the tipping point, if you will. So here's my function, for an example, y equals 1.001 to the x. And again, if you're working with pen and paper at home, I circle that power. So I circle that power, and I'm looking at the base. And I can see that 1.001 is just barely bigger than 1. But it still counts. It's still going to give me an exponential growth function because that highlighted part, the base of my exponent, is bigger than 1. And if I look at the exponential decay functions, if I circle the powers here, let me do that in red. If I circle these powers, you can see the bases of these exponents are all smaller than 1. And it doesn't matter what the number out front is. It could be 89 like here. It could be, 1 billion. It doesn't matter. I could put any number I want out here, but that's not the part that matters. What matters is what's the base of my exponent. So don't even worry about the number out front. Okay, so let's check out some examples. Number 1 here, I've got y equals 0.5 to the x power. So I'll circle that power, and I'll look at specifically the base of the exponent. Now, if it's smaller than 1, which it is, well, my function is going to get smaller and smaller. And that would mean that I've got an exponential decay. So over time, it's going to decay. It will get smaller. So this is exponential decay. Again, number 2, I'll circle the power. I'm going to look at the base. And since that's bigger than 1, that's exponential growth. So again, 1 is sort of that tipping point. Why don't you guys pause the video here, try the last 2 for me. So we circle those powers, and we're going to look at the bases. Now 4/7, if I type that into a calculator to check my decimal, 4/7 is going to be smaller than 1. And the way I can tell that here is my numerator is smaller than the denominator. So 4/7 is smaller than 1, so this is exponential decay. And here 9/5 is going to be bigger than 1 because 9 is bigger than 5. So this would be exponential growth. Okay. And the last two here, again, we're going to focus on these bases. So I circle the power, I'll focus on the base. 50 is clearly bigger than 1, so that's exponential growth. And last but not least, 11 divided by 65 is going to be smaller than 1, so that would be exponential decay. And our last piece of information here, 1 plus r to the x. We've got two variables to worry about. So A is the initial amount of bacteria. It could be bacteria or fish. Maybe your fish population is growing. Or money, if you invest so much money, some initial amount in the bank or in the stock market, you're looking at, is your money growing, hopefully, or is it decaying? Are you losing money? In the case of decay, you could think of you buy a car and it depreciates in value year over year. So what we're looking at here is it's a rate of decay if I'm subtracting here. So subtracting means that my number is going to get smaller and smaller over time. So it makes sense that subtracting would be decay. And you're going to look at the number that is, again, in the parentheses, in the base of the exponent. But you're looking at what am I adding or subtracting from 1 here. So R is our rate of growth or decay. And we're going to look at what am I adding or subtracting to 1. So for example here, let's look at number 1. I'm going to focus on the power here. So 1 plus 0.96. And if I'm adding, I'm getting bigger. That would be a growth factor, or the rate of growth. And it's that part that I'm adding to 1 that's going to be the growth factor. So my rate, my growth factor, is 0.96, or just 0.96. You could just put 0.96 and that would be fine. So that's the rate of growth, and the initial amount is 57. So this is always your initial amount. You don't need to change that number at all. All right, now let's look at number 2 here. 1200 is going to be that initial amount. And if I look at the number out here with 1, I'm subtracting, so that's going to be a decay function. And that rate of decay would be just 0.2. You don't need to include the negative here. The fact that it's decay kind of already tells me that it's subtracting or getting smaller. So we're going to look at these last 4 problems and then we will be done for the day. So let's just start with our initial amounts here for 3 and 4. So my initial amount is always that number out front. And our rates, here I'm adding 0.67. Here I'm adding 0.007. So both of these are going to end up being growth. So these will be exponential growth functions because I'm adding something to one. I'm going to get a number bigger than 1 here. And the growth factor is just whatever I'm adding to 1. And last thing here, I'd like you to pause the video and try these last two. So our initial numbers are the initial amounts, and those rates of growth or decay is just whatever I'm adding or subtracting to 1, to the number 1. So I'd like you to try